So today on the bench we've got a TM-G707 from Kenwood. Now this is in for repair. These are a 2 meter 70 SEMS FM transceiver, and they're basically designed for the amateur radio market. They come in 2 main variants. You've got an A and an E model. The difference between the A and the E, I think it's just the frequency coverage. It's just to accommodate different regions because they've obviously got different type approval criteria. They're a double conversion superhet receiver. You've got a first IF at 38.85 megahertz and a second IF at 450 kilohertz. And these have a 3-stage adjustable power output. So you can adjust from 5, 10 and 50 watts on VHF and 5, 10 and 35 watts on UHF. So these come with CTCSS as standard. They're also memory programmable. I think you can get up to about 170 memories on this. You can assign alphanumeric labels up to 7 characters per memory, and they have quite a number of, the usual refinements. Another thing that I do like about this, you've got a little socket here. This is a data socket. You can actually use this to send packet data, so you can hook it up to a PC. I imagine there's quite a number of other things you can actually do with it. The front panel is detachable, which I do like. I think that's pretty neat. And there would have been an option that you could actually buy an extender cable for these. If I could go back on, but you'd also have to extend the mic because that isn't included on the head, not like some models. So I believe these were manufactured from the late 90s into the 2000s. I'm not sure when they were discontinued, but there's a lot of Kenwood gear. They're quite desirable, and rightly so, because I don't know if you ever operated Kenwood or equipment or owned Kenwood equipment. They're quite easy to use, they're nice, they work well, they're reliable. And I do like this kind of radio, if I'm honest. They're nice, small and compact. They pack a punch. And they're ideal, you can take them mobile, throw them in the car. They're really robust, very good. You can easily modify these things as well. So you can actually extend the receiver coverage from 118 megs through to 174 megs. You can extend the UHF section from 300 to 520 megahertz, and you can also get them receiving between 800 and 999 megahertz. Now, how well they perform at that, I'm not sure. Also, the TX coverage range can be extended as well, which you can extend from 136 megahertz to 174 megahertz on VHF, and UHF you can get it to go from 400 to 520 megahertz. Now again, how well that performs, I'm not actually quite sure, but it's simply a case of removing I think 0 ohm resistors or diodes. That's what they normally are. Okay, so before we get into the repair, one thing I would like to ask is, if you're new to the channel, please like and subscribe. I don't have many subscribers, and it really helps the channel. So if you could do that, that would be great. Okay, so this has come in. The owner's basically saying that he's got a problem on VHF. And what it's doing is it's actually drawing excessive power. But it's okay on UHF. But when we go to VHF, it starts drawing power. Now, what I've done, I've connected this multimeter. This is just, it's Fluke 87. We're on, and I've just intercepted the 13.8 volts that comes into the radio, and so we can see the current it's drawing. Okay, so let's turn it on. Okay. So we're drawing 430 milliamps. Obviously we're in receive. And if we cycle through the band, okay, we're at 870 megs, that this has obviously had the modifications done to it. Okay, we're down at 134 megs, which is pretty much the air band. And then we go to 2 meters and we're drawing just shy of 4 amps, which is a bit odd. Now, that's quite a bit of power, you know. So if we calculate it at 12 volts, you know, that's 48. So that's 50 watts of energy that is going somewhere. So I don't know if the heat sink's going to start getting warm, but there's something going on. I mean, it's clearly receiving. We're getting some indication on here that on the S meter, that's not down low enough. So it could be taking off inside. I'm not actually sure at this stage. I mean, the first thing I would actually think, I'd go straight to the PA blocks. And the PA blocks in these things are generally made by Mitsubishi or Toshiba. They're the 2 big manufacturers in this type of equipment. But, yeah, that's quite odd. Go back. Yeah, we come out. She's low. Yeah, 400. 1.2 amps. So, yeah, okay, so at 1.2 amps at 134 megs. And we're drawing, oh, it's 4 amps now. So, yeah, okay, let's get it apart. Okay, so we've got the radio apart. This is the underside of the main board. It's only got 1 board in it. And I did notice after I'd left this on for a few minutes that the heatsink was actually getting quite hot. So that 50 plus watts of energy was having to go somewhere, which is pretty much telling me that it's coming from one of these modules. And when it goes into VHF receive mode, for some reason, one of these modules is switching on. Now, you know, it uses 2 modules, obviously, because we've got UHF and VHF. Which one's which, I'm not quite sure at this stage. But I noticed something quite interesting when we go into VHF receive mode. Okay, I've got the radio switched on. It's hard to see what mode we're in. And if I switch the band over to okay, so it's on 134 megs. It's now pulling 3 amps on the meter. But if we look on the monitor, we're transmitting at 173 megs, and we're actually transmitting at 2.55 watts. So that can be a number of things. I better just turn that off, because I don't want to do that for any prolonged period. So for some reason the VHF amplifier is turning on, and it shouldn't be. Now, there's a number of things here. We'll have to look at the circuit diagram to understand what's occurring here, because I've got a feeling that the VHF PA block is okay. I don't think there's anything wrong with it, simply because it doesn't do it when it's in UHF mode. And if we look at the schematic, it will become clear. Okay, so this is the schematic. And basically what we've got here is these 2 power modules. And one of them is UHF and the other one's VHF. Now, I think they're both Mitsubishi devices. Now, what's happening is, obviously, they're very straightforward. They're a complete block with amplification in them, and basically the RF goes in and the RF comes out. Now, they're being fed from down here. Let's have a look. So you've got there's a driver and a pre-driver, comes down, and ultimately it comes from this unit, and that's a VCO. So, well, I think it's a VCO, but anyway, that's where the signal's coming from. So I think, you know, obviously if it's generating RF, I think it's either going into self-oscillation when we put it into VHF receive. However, why doesn't it do it when it's on UHF? So if we look here, is that one or is it this one? Okay, this is a data sheet of the actual RF module. Quite straightforward. They've got 4 pins, and you know, so they're numbered there, and that's basically it inside. So what you've got an in and an out, and then we've got 2 power supplies. So one's for a driver and one's for the final, and that's it. And if we go, you know, it goes through. It tells you that. Here it just tells you obviously the characteristics of the device. So if we go back to the service manual, look on the schematic here, oh, if we can get it to settle down. Okay, so we've got a power supply here, and we've got a power supply there. Now this power supply, this is for the final device that's in there, the final PA, and that comes down here, and it's connected directly onto the 13.8 volt rail. So that's not switching at all when we switch from UHF to VHF. It's just on, and it's the same. It just links over, and it also feeds the UHF module. And then if we look here, this is the second module. Now these two are linked again, and what this is basically an ALC or an APC as they're calling it. And if we look here, if I can zoom in, that's this rail coming down here. And basically what this is doing, there's a comparator here that's sensing the RF from the output. If we have a look, yeah, if you follow that down, that senses the RF from the output. There's a comparator circuit, and obviously they'll control the voltage here, switches this device on, which switches this is a regulator transistor, and that will control the gain level of these amplifiers. Now again, they're joined together, so I don't think there's anything wrong with these circuits here, simply because they you know, if there was an issue with it switching on or off, then the unit would be, you know, causing problems when it's in UHF, and you know, at the moment it's not doing that. So if we look further down the circuit, here we go, we've got, where is it? Okay, yeah, we've got this rail here. Now that's your VHF TX rail, so it goes to 8 volts when you're in VHF mode and you key the mic, and that will go high to 8 volts, which will obviously supply power to these transistors. But it also comes down here, and there's a little diode here. This is a switching diode, this D6. Now if that goes high, it'll switch it on, and what I suspect is happening is either this TX is coming on for some reason, the TX8 or the VHF TX8 is coming on, so that's what we're going to test, or there might be something wrong with this diode, because this coming out of here, this signal will also go down and be used by the receiver, so that'll get mixed up as part of the you know, the receiver, as part of the receiver mixer, I would imagine. So I'd like to look at that. So these are the two, this is what I'm going to look at. We want to see if this is not this in receive, that should be 0 volts. And if it is, then I think we've got a problem here with D6, because if it's gone short, and which I suspect it may have done, then this is still getting a signal of sorts. But then, you know, it shouldn't be amplifying, but it doesn't, I don't think it needs much. You know, we probably get enough to get bleed through and to start activating this. Well, I think that's where the problem may lie, and we're only going to find out when we put the meter on there and see what's occurring. Okay, well, I am on the VHF TX8 and we're in receive mode and it's switched on. We're getting 7.21 volts on that rail. I better switch it off. I don't want to, I'm sure it's not doing it any good. Okay, so let's go back to the diagram. I think we need to check the switching devices. Okay, so this is our VHF TX8. And we tested this and it is staying high when it's in receive mode. So the reason, I guess, that it doesn't do it on UHF, because our signal's coming from this VCO and I guess that shuts off. So there's nothing to amplify. So it's literally amplifying the this signal. And the frequency changes when you go to, you know, from transmit to receive, because it's got to put the IF shift on it, I guess. So, and that's where this goes. It goes down and gets mixed up in the front end of the receiver. I imagine that's going to the first, that's the foot makes up the first LO. So, where is this coming from? Well, if we follow it down, it comes down here, it's on this rail. Comes across, it's on the next drawing. Was that the one up here? Now these drawings, you know, these schematics aren't the best. However, they are legible, and it's a hell of a lot better than not having anything to use. So imagine that's it there. Comes down. Let's have a look at you. It's here, isn't it? Yeah, so it's this one here. Let's have a look. It's this one here. Okay. And that's a little PMP device. So that's our RX8. Sorry, TX8. And it's for the VHF TX8, and that's being fed from here. In fact, it says it VTX. So this is a shift register. I imagine it's just getting a bit of serial information from the microcontroller, and this will switch on. And as it switches on, yeah, oh sorry, it'll go, yeah, it'll be on, and then it'll be high, and then when we need to go into TX mode, that'll go low and switch this on, and this will be that is the common 8 volts. So we need to test this transistor. Now it could well be this that's doing it. It's got a little pull-up resistor. Obviously it's a PMP, so they work opposite to NPN. And so if that's being pulled up, this will be switched off. If this goes low, this will switch on the this rail, which is, you know, which we know's on. So yeah, let's test this device. So this transistor here, this is a PMP switching transistor. It's a 2SB 1132. They're made by Rome, and if we put the diode check on it, one side's the center one's the collector, and that's the emitter. Yeah, we've got a dead short. Okay, well that goes back to a shift register. I think there's a resistor in the way, so the shift register should be okay. So I'm going to order one of these, and you know, then we'll fit it in, and hopefully she'll be back in health. Okay, well you can see I've actually removed the device. I tested it again on the continuity meter, and yeah, it is dead short. I've put it in this little tester, a little Chinese tester. I actually quite like it. It works quite well, and I've managed to tack on some little legs to get it into the socket. So let's see what it makes of it. I was thinking about it. Move the light out of the way. This is the transistor we've removed. It's a 2SB 1132. Now this is a 32 volt 1 amp device. It's in a SOT 89 package, and they look pretty much general purpose. Obviously it's PMP. So I had a bit of digging around on the Farnell website. They've got a transistor comparator, and I found this. This is a 2SB 1122, again PMP device in a SOT 89 package. This is 50 volts at 1 amp, and in the applications it's saying here it's used for regulator, relay drivers, lamp drivers, electrical equipment and such like. So it's a pretty much general purpose transistor. Well, the parts have arrived. So let's see what we've got. Okay. It's always tricky. Okay. Oh, that looks just the jobby. Okay. Okay, so if we put what I'm going to do is just put a little blob of solder on here, just a little bit. Take a look. Yeah, just like I bought one. Okay, so we've got the power on, and we're in 2 meters, and we've dropped to 378 millivolts, which, you know, obviously before it was actually idling at 400 across all the, you know, UHF and VHF, and that's probably because that TX rail was switched on. You know, it's switching on the driver circuit, which of course is going to draw current, but that's settled down. We've got no interference at all. And if we key up, yeah, it's switching. We'll just check the voltages, but that's good. I have tested this on full power. It seems to be working fine. I don't want to do it on the meter because this is only rated at 10 amps, and I really don't want to blow the fuse in it. So, but yeah. Okay, we set up. I obviously commoned the negative with the power supply, and if we just check, oh hang on, I better turn it on, haven't I? Okay, and if we just check that collector voltage now on the new device, if I can stop shaking, that is. Yeah, okay, so yeah, that's 100 millivolts. That's probably coming from somewhere else. And if we key up, yeah, it's switching to 8.22, so that's the 8 volt rail, and she's now switching correctly. And if I just move this onto, I don't think you won't see it, I'll take that onto 70 sems and key up, yeah. Yeah, that's good. Okay, well, if you've watched all the way through, I'd say thank you very much for watching. I would do appreciate your support, and we'll catch you in the next video.